Hey, Mr. Richards here. Today's 6th grade Unit 6 Lesson 9 Anchor Problems. In Problem 1, the statements below describe how much money 4 different people have compared to $5. For each statement, name a few values that fit this situation, write an inequality to describe all of those solutions, and draw a graph of the inequality on a number line. So if we go to number 1, Caleb has at least $5. Well, if Caleb has at least $5, is $5 true? Yes. How about $6? Is $6 at least 5? Yes. 7, 8, 9, and so on. And so it looks to me that we have x would be greater than or equal to 5. His money, x, is greater than or equal to 5. As we draw out a number line here, we can put that 5 in the middle, and at least one number to the right in the bigger, so 6, 7, we can do 2 numbers. A couple numbers smaller, 4 and 3. And when we go to shade in these number lines, what we're looking for is shading in the direction that it's true. Now, 5 counted, so we can shade in the circle. We're shading towards the right, 6, 7, 8, 9, where the inequality was true. And we draw this as a ray with the arrow on the end, indicating that all the numbers, including 100, 2,000, 5,000, are true for Caleb having at least $5. Number 2, Tarek has more than $5. Well, is this different than at least $5? Is $5 more than $5? No. So $5 actually is not true. What about 6? Is $6 more than 5? Yes. 7? Yes. 8, 9, and so on. And so the difference between Caleb and Tarek is Tarek's inequality is going to be written as x is greater than 5 or bigger than 5, because here's another number that's true that we didn't write. Well, $5.01. That's true. And so we're going to write this as x is greater than 5. And for our number line, it's going to look very, very similar to Caleb's, with the 5 in the middle. A couple numbers bigger, 6, 7. A couple numbers smaller, 4 and 3. The difference, though, is we are not going to shade in the circle because 5 is not true for this inequality. And so we'll shade up towards where it's true. So 6, 7, and so on. The nice thing about this number line is it also does include this $5.01 over here. So we want to start this with an open circle at 5, shaded to the right. Now Vanessa has at most $5. How is this one different from the rest? Well, if she has at most $5, is 5 true? Yes, it is. I mean, 5 is at most 5. Is 6 true? No. What about going backwards now? 4. Yeah, $4 would be at most 5, 3, 2, 1, and so on. So this number line and this inequality, it looks like x is going to be less than or equal to 5. So as we sketch this number line out, again, with 5 in the middle, a couple numbers bigger, 6, 7, a couple numbers smaller, 4 and 3. We're going to shade in the circle at 5 because 5 was true. And shading back towards the 4 and the 3 and drawing our arrow so it's a ray that way. And then lastly, Li Shen has less than $5. Is 5 true? Is 5 less than 5? No. What about 4? Is 4 less than 5? Yes. Is 3 less than 5? Yes. 2, 1, 0, and so on. So x is going to be less than 5. And so as we draw out our number line, We'll put 5 again in the middle, a couple numbers bigger, 6, 7, a couple numbers smaller, 4, 3. We're going to keep the circle open because 5 is not less than 5, but we'll shade back in this direction to the left where it gets smaller. So we include 4, 3, and again, we also are including numbers like $4.99 when we graph it this way. Instead of starting at 4, we have an open circle at 5, shaded back to the left. And so some of the differences here, when they're or equal, that includes the value, and so we shade in the circle. When it's just greater than or less than, we keep the open circle because it does not include the value. Problem 2. At SeaWorld San Diego, kids are only allowed into the air bounce if they are between 37 and 61 inches tall. They are only allowed on the tide pool climb if they are 39 inches or 39 inches tall or under. And you can see the signs here, air bounce, see between the 37 and 61 inches, and then another sign that must be 39 inches or under. So A, represent the height requirements of each ride with inequalities, show the allowable heights for the rides on separate number lines, and describe the height of kids who can go on both the air bounce and the tide pool climb. For air bounce, it looks like they need to be between 37 and 61. And so if we just kind of abbreviate this AB as air bounce, we think about some numbers. If you're 37 inches tall, are you okay? Yeah. 38, yeah. And all the way up to 60 and 61. So what we need here on this number line is a inequality, or a number line that goes in between 37 and 61, and we're going to have the numbers shaded in because 37 and 61 are both true, and we're just going to shade in between here. Now this inequality is technically 37 less than or equal to x, so x is greater than or equal to 37, but x is less than or equal to 61. So it's kind of called a compound inequality. Now, getting to tide pool climb. Abbreviate this as TP, not toilet paper, but tide pool. Sorry. Recording this upstairs today, so I got a gallery of people laughing. Can you be 39 inches tall? Yes, you can be 39 or under. 40? No. 38? No. 37? Yes. So 39, 38, 37, 36? Yes. Go away. And if we draw a number line for this, we'll start this one at 39. And really, I mean, this is kind of going to go to maybe, if you think about it, 0, because you can't be a negative. And so if we go from 39 to 0, we're going to be in between the 39 and the 0. And so I would write this one out, 0 on the low end. So x is greater than or equal to 0, but x is less than or equal to 39. And so when we look for where are they intersecting, where are the kids that can go on both the air bounce and the tide pool climb? Well, we know 37 works on both. We know 38 worked on both. And we know 39 works on both. If you look at this number line, you can kind of visualize that between 37 and 39 is where it's true. And so for both, I would make the argument that you have 37, 38, and 39. And so on a number line, we can sketch this out as being between 37 and 39. And we can shade this in 37 between 39. And so 37 is less than or equal to x is less than or equal to 39. So as long as you're between 37 and 39 inches, you can write both. Problem 3, for each inequality below, draw a graph to represent all the solutions of the inequality. X is greater than 20. Well, if I put 20 on the number line, we'll put this right here. We think about some values that are bigger, 21 and 22. Think about some values that are smaller, 19 and 18, and you do not need to complete this entire number line. If we put an open circle at 20, let's test these values. Is 19 greater than 20? No. Is 18 greater than 20? No. Is 21 greater than 20? Yes. Is 22 greater than 20? Yes. And so this number line is being shaded towards the right in this direction where the inequality is true for all of the values. Do we shade the circle? Is 20 greater than 20? No. So it's going to stay an open circle. Now, I'm glad they have a variable on the right side here in this example, because too oftentimes we just look at the inequality and go, oh, it's pointing towards the right. Let's shade towards the right. That's not going to be true if the variable's on the right side. So as we go to this one, I'm going to graph this one over here just because. 2 is our point. A couple numbers bigger, 3, 4. Couple numbers smaller, 1, 0. Now, put in these numbers. It is pointing to the right, but are we shading to the right? 3. Is 2 greater than or equal to 3? No. Is 2 greater than or equal to 4? No. Is 2 greater than or equal to 1? Yes. Is 2 greater than or equal to 0? Yes. And so this actually is shading back towards the left. And so don't get stuck in the pattern that, oh, it's inequality is pointing in this direction. I have to shade it this way. Is 2 greater than or equal to 2? Yes, so we can shade in the circle. And lastly, m is greater than negative 4. Start at negative 4. Have a couple numbers bigger, a couple numbers smaller, and test. Is negative 3 greater than negative 4? Yes. Is negative 2 greater than negative 4? Yes. Is negative 5 greater than negative 4? No. And so we're shading it towards where it's true, which is the negative 3, negative 2, negative 1, 0, 1, 2, 3, and all that in that direction. Do we shade the circle? Is negative 4 greater than negative 4? No, it is not. And so that is it on graphing these inequalities. Good luck.